So today I want to continue with 10.6 determinants and Cramer's Rule. 10.6 determinants and Cramer's Rule. So in this section we are going to learn a new rule for solving systems of equations, namely called Cramer's Rule, and it uses determinants. So let's first discuss determinants. The determinant of a 2 by 2 square matrix, of a 2 by 2 matrix A, which is A, B, C, D, is the real number. So once we have a determinant, instead of brackets we use straight lines. That means we're doing determinant of the matrix BCD, and it equals, you multiply the entries along the main diagonal A times D, you multiply the entries along the secondary diagonal B times C, and then you subtract those products in that order. This is first and this is second. It's very important to do it in this order: first, second, first, second. That's if you're doing determinant of 2 by 2. Here's an example. So when I say evaluate and I give you something like this, 2, 3, -1, -3, so it's a determinant of a 2 by 2 matrix. So we do that first. 2 times -3 is -6, minus 3 times -1 is -3, so -6 plus 3, which is -3. Although determinant looks like an absolute value, but it's not an absolute value. You can see the answer can be anything: positive, negative, or 0. So how do we find the determinant of a 3 by 3 matrix? The determinant of the 3 by 3 matrix write it like this. So A, C, D, E, F, G, H, I so that determinant is obtained as follows. It's gonna equal, so we're gonna reduce the 3 by 3 matrix into 2 by 2 determinants called minors. 3 by 3 determinants called minors. So we can reduce along any row or any column, but for simplicity, I'll use the first row. I'm going to start with the top entry. It's an A, bring it down, times the minor of A, M11. Why 11? Because A is in the first row and first column. I'll explain what that means. And then B, leave a space for the sign, times the minor of V, which is the minor in the first row, second column, and then C times the minor of C, which is in the first row, third column. And the signs, they will always alternate. So this will always be plus, minus, plus. Plus means you keep the sign of A, even if A is negative, you keep it negative. Minus, you do the opposite of V, and plus, you keep the sign of C. So plus, minus, plus. Now what are those minors? To find, say, M11, where M11, it's the 2 by 2 determinant that you obtain by crossing out the row and column of A. So A, you cross out the row and column of A, you get E, F, H, I. That's your minor determinant of those values. M12 is the determinant you obtain by reducing the row and column of V. The row and column of V. So it'll be D, F, G, I. D, F, G, I. And then finally M13, it's the determinant that you obtain 2 by 2 determinant by reducing the row and column of C. Row and column of C, so it's D, E, G, H. And once you get these are numbers, you find them, then you times them by A, B, and C and get your result. So here's an example. Evaluate determinant two, -3, -1, -1, 3, 2, 5, 7, -2. So we start, remember we're always going to do the first row. We start with the 2, it's a plus, remember plus, minus, plus, so you keep sign of 2 times the minor of 2. You cross out the row and column of 2. So basically the row and column of 2 you cross out, so it's going to be 3, 2, 7, -2. 3, 2, 7, -2. And then this minus tells me I do the opposite of -3, which plus 3. You cross out the row and column of the 3, so you get -1, 2, 5, -2. -1, 2, 5, -2. This plus tells me to keep the sign of this number, so it's -1. You cross out the row and column of -1, and it's -1, 3, 5, 7. And now we just learned how to do 2 by 2s, so let's do that. And then times it by 2. 3 times -2 is -6, minus 7 times 2 is 14. We'll do that later, plus 3. -1 times -2 is 2, minus 5 times 2 is 10, and then minus 1 times -1 times 7 is -7, minus 5 times 3 is 15. So this is -20 times 2 is -40. This is -8 times 3 is -24. -22 times -1 is 22. So you end up with -42. Now we can check this work by using our calculator. I'm going to show you this once on the calculator, but remember you got to show the work on the test. So first we got to key in the 3 by 3 matrix. We learned this last time. It doesn't hurt to do it one more time. So edit matrix A, it's a 3 by 3. So 2, -3, -2, no, -1, sorry. And then -1, 3, 2, and then 5, 7, -2. Once you add the matrix, you check the entries, make sure you didn't mess up any sign or any number. Then you exit, second quit, and then go back to the matrix. Second x inverse, you want to do some math. The first item is determinant. You want to do determinant of the matrix that was edited, which is matrix A. So we're going to do second matrix, retrieve matrix A by hitting enter. Determinant of A is -42, as we know. Okay. So remember we talked about the inverse of the matrix last week in 10.5, and one of the, if you remember, we did determinant, we did the inverse of matrix A, and it was 1 over AD minus BC, which is, this is actually determinant of matrix A. And we say the determinant a matrix has an inverse if and only if its determinant is not 0. Because if you have a 0 under 1, it's only fine, that's why, okay? And remember it was D, A, -B, -C. If A was A, B, C, D. That was the inverse of a 2 by 2. Okay? Now we're going to use determinants to solve systems of equations. This is called Cramer's Rule for solving a system of 2 equations. So to solve the system a1x plus b1y equals c1, a2x plus b2y equals c2. Solutions are x equals dx over d, y equals dy over d, and notice the same denominator in both of them. But what are those d, y, and dx? Where d is the determinant of coefficients, so you put the x coefficients in the first column, a1, a2, you put the y coefficients in the second column, b1, b2, and you find determinant, 2 by 2 determinant, dx. You put the constants in the x spot, and you keep the y's in their spot, b2, dy, you put the x in their spot, a1, a2, and then the constants in the y spot. And you find d. If d is 0, you say Cramer's rule fails. Why? Because you can't have 0 at the bottom. You can have 0 for dx, 0 for dy, but not for d. We Cramer's rule fail. And what does that mean? We have to use elimination of substitution. That's not gonna work, okay? So if d is not 0, then x equals dx over d, y equals dy over d. That's gonna give you the answers. So use Cramer's rule, and on the test when I say use Cramer's rule, you better use Cramer's rule, okay? To solve 2x minus 5y equals 9, negative 3x plus 4y. So when we say use Cramer's rule, the system has to be in general form, x, y constant, it is. We find d first, because if d is 0, we don't want to do dx or dy, we have to do something else. X coefficients, y coefficients, so 2 times 4 is 8, minus negative 5 times negative 3 is 15, d is negative 7, as long as it's not 0, we go on. Dx, we put the constants in the x spot, and then the y's stay put. 9 times 4 is 36, minus negative 10 times negative 5 is 50, that's negative 14. Dy, we put the x coefficients in their spot, the constants in the y spot. 2 times negative 10 is negative 20, minus 9 times negative 3 is negative 27, so it's just 7. Now x dx over d, y is dy over d, so negative 14 over negative 7 is 2, 7 over negative 7 is negative 1, so 2 negative 1 is the solution. So that's 2 by 2, same thing for 3 by 3, but it's a lot more work. So Cramer's, I'm not gonna write down the details because they're in the notes. So to solve a system of 3 equations, same idea. As long as d is not 0, x is dx over d, y is dy over d, and z is dz over d. D is the same in all denominators. If you have 0 in the denominator, then we have to do elimination, it won't work. So to find D, as usual, we put the x coefficient first column, the y in the second column, the z in the third column. To find dx, we replace the x coefficients with the constants. Oops. Okay, and then we put the y's and the z's in their spots. To find dy, we replace the y's with the constants, the x and the z stay put. Find dz, we put the constants in place of z, a, x, and y stays put. If d equals 0, Cramer's rule fails. Otherwise, x equals dx over d, y equals dy over d, and z equals dz over d. So here's an example. So solve using Cramer's rule. x minus 2y plus 3z equals negative 1, negative 2x plus y minus 5z is 1, and 3x plus 3y plus 4z is 2. Okay, so everything is in standard form, so we start with D, because if it's 0 we stop and then we do something else. 1, negative 2, 3, negative 2, 1, 3, 3, negative 5, 4. So again, keep the sign, opposite, keep the sign. So 1 times its minor, which would be 1, negative 5, 3, 4. Opposite of negative 2, you change the sign of negative 2. It'll be negative 2, negative 5, 3, 4. Keep the sign of 3. Negative 2, 1, 3, 3. So D is 1 times 4 plus 15. It's 2 times negative 8 plus 15. 3 times negative 6 minus 3. So you get 19. And that's be 7 times 2 is 14. Negative 9 times 3 is negative 27. It's 6. Okay, so that's D, dx. I'll just do D and dx. You can, I have the result for the rest, so you can do them on your own time. You replace the x values with the constants, and then you keep the y coefficients and the z coefficients. So again, keep the sign of negative 1, opposite of negative 2, keep the sign of 3. So negative 1 times the minor, which is 1, negative 5, 3, 4. Opposite of negative 2, that's 1, negative 5, 2, 4. And then plus 3, 1, 1, 2, 3. So this is negative 1, and then 4 plus 15. 2, 4 plus 10, plus 3, 3 minus 2, negative 19, 28, and then 3, and dx is 12. So same thing, you can get dy is 0 and dz is negative 6, x is dx over d, dx is 12 over 6, which is 2. Y is dy over d. 0 over 6 is 0, and z is dz over d. Negative 6 over 6 is negative 1. Okay, one application using determinants is finding the area of a triangle. Can you imagine? Let's see how. Area of a triangle. If you have 3 points that make a triangle, A is A1, B1, B is A2, B2, and C is A3, B3. So basically you have A, B, C. A is A1, B1, B is A2, B2, and C is A3, B3. Are 3 points in the plane. Then the area of triangle ABC is, area is plus or minus 1/2 times the determinant. You put the x values in the first spot, y values in the second spot in the same order, and then ones in the third spot. Always ones, always. These are the x, and these are the y. And the plus or minus, because you remember determinant could be negative, so plus or minus to keep it positive. If it's plus, you don't need that. If it's minus, then you change the sign. Okay, so here's an example. Find the area of the triangle formed by the points A, -2, B, 35, and C, 2, -3. So area equals plus or minus. You put the x values here, so -1, 3, 2. The y values 2, 5, -3, and all ones. X, y, all ones. So leave the plus and minus alone. That's just to adjust sign if it was negative. So remember plus minus plus. So plus -1 times the minor, which is 5, 1, -3, 1, minus 2 times the minor, which is 3, 1, 2, 1, and then plus 1 times 3, 5, 2, -3. So it's -1 times 5 minus -3 minus 2 times 3 minus 2 plus 1 times -9 minus 10. So that's -8, that's minus 2 minus 19, which is -29, and I forgot the 1/2, sorry. It's plus or minus 1/2, so it's half. So it's 29 over 2 square units. What happened to the negative sign? Remember, there's plus or minus, so we're going to put minus negative, which is a plus, so we can get an A. And that's it for 10.6. Until 10.7, see you then.